Net ionic equation. So there are three types of equation. We have one, non-ionic equations. So this type of equation shows that all reactants and products as if they didn't disassociate in a solution. So here's our examples here, where this is just our simple double replacement reaction. Okay. Now we have a total ionic equations. So this type of equation is more accurate, and it shows all the soluble reactants and products disassociated into ions. So this is saying, okay, I've mixed these things all together in solution. This is they're all disassociated. Then what I'm going to end up getting is I'm going to get this one solid, and then I'm going to have these other ions floating around. Okay, so this is the more accurate type. Okay, then we have net ionic solutions. So this type of equation shows that only the chemical change that occurs. So spectator ions, which are ions that don't change in the reaction, are cancelled. Okay, so here if we look, my nitrate ions cancelled out, so do my potassium ions. So in this case, all that we're dealing with in the net ionic one is the lead and the iodine forming our solid. Okay. So for example, aluminum sulfate and sodium sulfate. Well, here's our double replacement equation. Okay. We notice that 3 of them are aqueous, only 1 is solid. We're going to balance this out. Now we're going to write, looking at specifically only our ions. Okay, we've got that these ions being contained. Okay, then we're going to cancel out now the ones that don't change, meaning that we get this net ionic equation. Okay, barium hydroxide and aluminum nitrate. Again, we do our double replacement. Okay, we formed one solid. We need to balance this lovely thing out. Now I've got all of my ions that go in, and these are going to turn into my products. I'm going to have this one solid product. Then I'm still going to have the barium and the hydroxide ions, the nitrate ions floating around. Okay, we're going to cancel those out because nothing really changes with them. So my net ionic equation is just this formation of the aluminum hydroxide. Okay, and we can then bring that down even farther, as we see here, just to cancel out some coefficients. Okay, fluorine gas and sodium chloride. Again, here we've got a single replacement. Alright, so it's just this knowing that we're going to pump one gas in, but we're going to get another gas out. Okay, balance it. We've got our ions. Okay, going to chlorine gas, and our sodium ion, and our fluoride ions. We need to cancel out the sodium because those guys don't change. So now we just have the fact that fluorine gas and the chloride ions will change into chlorine gas and fluoride ions. Okay? In the next video we're going to talk about qualitative analysis.